how to interconnect millions of players all around the world. Now, there's actually many more components and pieces that go into game development, but these are the big three that we're going to cover in this presentation. So looking a little bit more into source code. We had to start to get a handle of what we had to work with. And for source code, we kept track of everything in a repository that keeps track of every change that's ever been made. So here it was simply a matter of going to that repository and asking, what is the first change you know about? How far back does your history go? And it turns out this repository has been tracking changes since 1997. Now, before you go to jumping to any conclusions, this doesn't necessarily mean that World of Warcraft itself has been in development that long, only that it contains some shared and generic bits of code that started the Warcraft lineage. Now, of course, no source code repository would be complete without bugs. We happened to also find the very first bug fix in our repository shortly thereafter. A few people are ahead of me. The joke here is that this little bit of a function claimed it was going to do one thing, but literally did the exact opposite. Very first bug fix in Warcraft's history. Given that we have been tracking every change since 1997, we've had a high degree of confidence in our ability to restore this major component from the original version of World of Warcraft. Next up, I want to talk about how we worked with our database data. Now, to shed a little bit of light, early on, we only had really a simplistic model. There were two versions of the game. There was the version that was live and available to the public, and the next patch that we were working on. Once we were ready to release that patch, we would push it to the live services and make it available to everyone. Now, this had, we would immediately then turn around and start working on the next patch, but we were doing it directly over the previous data. This had the unfortunate side effect of some amount of data loss in some of these earlier patches. We also encountered other problems here in that the team could only ever work on one patch at a time. This was quickly rectified, and we're now able to work on multiple patch schemas at a time. So when going back and looking at our database data, we took our clock, we cracked open this database and said, how far back do you still have data for? Fortunately, we still had 112 and slightly before. So this gave us sort of a medium level of confidence in our ability to restore original database data. Next up, I want to talk about art assets. There are many types of art assets. Some of the most familiar are what we call 3D models. And these are comprised of vertices, which are simply points in three-dimensional space, and indices that tell us how to connect these. Also, hopefully familiar, are textures. These are paintings and colors that are drawn on a two-dimensional canvas. We can take these various art assets, and once we start combining them, we're able to see a few familiar faces. Now, with art assets, we store those on some network storage that we have. And so when we went digging, we unfortunately found that we only had a few of the more recent art assets from the more recent expansions. But this project was very important to us, and we went all the way to our data archivists and asked, do you have any old backups of these old network drives? We need them. We desperately want to go back to the original data. Now, this data was actually off-site, and we weren't sure what we were going to find until some of the old backups were restored from very old tape drives. We did receive a backup from 2008, and we thought, well, the date's good, but not exactly what we're looking for. We dug into it a little bit more, and fortunately, we found on that backup a folder labeled Final 112 Data. Yeah, that's right. We found a backup on our backup of a backup. So, now that we have 112 versions of these three major components, our source code, our database data, and our art assets, we're ready to attempt to reconstruct 112 with these pieces. We shoved them all in a blender, and to our amazing delight, we had a version of 112 that we can launch and run internally. We were able to log in. We can create characters. Could level up and do all the things that we remembered. And this was an amazing milestone for us. But we then needed to take a step back and think about what this version really meant. It's important to understand that our services, that this version of the game was engineered for a much older version of the internet. This version didn't understand how to run in our modern Blizzard cloud. We also realized that our game servers don't operate in a vacuum. They're an integral and important piece of a larger Battle.net Blizzard network framework, which includes things like account management and authentication. This version was also unable to work in our content delivery pipeline, so there was no way we could put this version on our Battle.net desktop app. Again, without access to authentication, there were no login servers it could talk to. There was no way this version could talk to our customer support systems. You couldn't enter GM tickets. But really, most harsh of all was that every bug, every problem, every exploit would instantly come screaming back. And not only that, they would already be known to some number of malicious people out there. Clearly, this version, as it stood, as it was, didn't really reflect the highest levels of Blizzard quality that we come to expect. But we weren't quite ready to give up. We took a long, hard look at what we had built so far, and we thought a lot of what we don't like about this version is in the source code. It still had a lot that we really loved. We loved the database data, and we loved the art. So we gave ourselves a little bit of a thought experiment. What if we brought up our modern database data, our modern high-resolution art, and modern source code, threw away what we don't like about this version, strip out the more modern components, and simply layered what we liked about this old version on top of what we needed in our modern tech stack. I remember standing around a room where we all looked at each other, and no one was quite sure whether this was a good idea or not. Was this viable? Would this work? And the reason for that has to do with how these pieces sort of fit and integrate with each other. That in these seams and these interconnects, those have also changed and evolved and improved over time. So when we thought about this plan, we realized very quickly and early on that these pieces, they just don't fit. The new source code doesn't know how to load the old data. But again, we all love World of Warcraft. We all love those memories, and we all long to go back to it. So we gave ourselves a little bit more time and thought, is there really no way to kind of force this together? What would that even look like? We gave ourselves a little bit of research and development time, and we thought, well, let's just work on transforming this data, see if there's a way that they can meet in the middle. What does that experience look like? Should be a video clip of that. So here we have a very early prototype. This was effectively a 7.3.5 client and server with its database data stripped out and imported from the 1.12 version of our data. We had a lot of systems that we liked. You could still cast your fireballs. You can kill creatures. The spawns from 1.12 were there. The drop tables had worked. A lot of the server-side elements were there, which included things like having to learn class abilities, even if you didn't have enough money to buy them at the time. True to form, you might have to leave and come back sometime later once you ground up that little extra copper. Now, of course, this was a very early prototype. We were forcing this data in, and it still obviously wasn't going to work out quite right as is. Had errors, problems, but this is an important piece of research and prototyping. Combat wasn't quite there. We found ourselves stopping to drink way too often. But really, the core of the game was there. You still leveled up. You still bought your spells. You still turned in your quests, and you still leveled up. The core pieces of the World of Warcraft nugget was there, but it was running on our modern infrastructure. This was what really gave us the proof that this was a way forward, that this could actually work. This insane idea would lead us to World of Warcraft Classic. And now, to talk a little bit more about the challenges of going from proof of concept prototype to full-blown production, it's my honor to introduce lead engineer Brian Birmingham.
Hello, BlizzCon. My name is Brian Birmingham, and I'm the lead software engineer on World of Warcraft Classic. I am a huge fan of retro gaming. I love to go back and play old games from my past, games that I played growing up, and World of Warcraft is certainly one of them. I've been playing since the beta, and it's just a great game that captured my heart even back then. But when I heard that World of Warcraft team was going to make WoW Classic, I jumped at the opportunity to come back and lead this team. But it's not my first time being on the World of Warcraft team. I first joined Blizzard in 2006, and I was on the World of Warcraft tools team. And at that time, I joined to help ship Naxxramas and to improve the way that we make World of Warcraft. I spent the next 8 years doing that. And then some of the other things I did were take the database data as it evolved over those years and convert it to each of our new expansions. And so in some ways, this project is like replaying all that work again in fast forward. I want to talk about these building blocks that Omar mentioned. These building blocks come together to create some of the things that you recognize as players. Things like terrain, the gameplay systems, the animations, and the lighting. And the first one of these that I want to talk about is terrain. Terrain is the heights of the mountains and the valleys. It's the placement of the trees and the buildings throughout the world. It's the water that's in the lakes, the rivers, the streams, the oceans. And there's a reason why in the prototype that you saw from Omar, we were in Dunmoreau. And it's because that terrain was unaltered by the Cataclysm. So it weren't perfect for that first prototype. But if we were to venture just a little bit outside of Dunmoreau and into Loch Modan, you start to see some kind of funny things. Like these Threshodons that are supposed to be swimming, but they're walking around on land, and they seem to have built these little Murloc huts for themselves, and that's not right. There's also this purple cape on the gnome, and that's odd. That's not like an epic. That's missing texture purple, and I'll talk about that a little bit more later. For now, let's focus on the fact that the water is missing and that those are the wrong buildings. If we go to other places, like, say, Thousand Needles, we'll find water that shouldn't be there. And there's Kolkar camping underneath the water and building fires. So this is also not okay. So we said, okay, just like we did with the data, what if we take these terrain files, these old terrain files we found on that backup of a backup, and we fed them to World of Warcraft Classic, to our modern engine? Would this work? No. This doesn't work either. And the reason is those puzzle shapes that Omar mentioned. Things don't fit together. Imagine this is the shape of the 112 terrain data, and our 112 engine expects that shape. So if we feed it the 112 terrain data, it fits perfectly. Our reference client that we built understands exactly where to find all of these pieces. Our modern engine expects the same pieces, but in slightly different places. And so when we feed it and of course our modern terrain data fits it perfectly. If we feed it the 112 data, it doesn't fit perfectly. It finds some things where it wants to find them, like the terrain heights and the water and the grass, but it doesn't find the object placements from 112. It finds the new ones instead. So to give you an example of what that looks like, I have another video, again of Loch Modan here. So here you can see some of the buildings look okay. But as we start to fly out over the lake, which now has the water back, you can see some trees that aren't supposed to be there. Those are object placements. Those are burned trees from the Cataclysm. And then a tree flying in the middle of the air, and that's clearly not right. There's some misplaced buildings from Grim Batol. And if we turn back toward the dam, you can see the dam is shattered. And yet somehow, even though the dam is shattered, it's able to hold back the water. So here we said, there's clearly more work to do here. And our modern tools come to the rescue. It turns out that we have modern tools that we've been developing over the last 14 years that know how to read our old terrain data. they also know how to produce our modern terrain data. And so then we can take that terrain data after it's been converted and give it to the modern engine. And then the modern engine finds everything that it expects to find exactly where it expects to find it. And now the dam is restored. Our tools are really important to this. So we spent some effort on these. We wanted to make sure that our tools could work not only on Battle for Azeroth, but also on WoW Classic at the same time. This was some effort, but we thought it was really worth it because World of Warcraft Classic is not a small side project. This is a fully integrated effort that has the full support of the World of Warcraft development team. I want to talk to you about some other art assets. We've talked about models, and they're not just the character models or the creature models, but also those trees, those huts, the buildings, the lampposts. Why is that lamppost purple? Is that lamppost supposed to be purple? We have the reference client. Let's check. No, it's not supposed to be purple. It's supposed to be white. So why the difference? That's the same model. Why doesn't it look the same? And the reason it doesn't look the same is that we've made a change in the way our engine handles errors. In this case, in 1.12, we displayed, when there was a missing thing, a white light. So in the case of the gnome's cape, you remember it was purple. And in the case of this light, this lamppost, it's purple as well. And it's because something's missing. We set up this model, and we told it that it should emit a light, but we didn't say what color it was supposed to be. And our engine in 1.12 said, when I don't know what the color is supposed to be, I display white. And then we don't notice that there's a bug. We never noticed. So in our modern engine, we say, you know what? Let's display purple. Then we will notice. If I see purple, I know I have to do something. I should investigate at least and find out what the problem is. And in this case, we don't want to do what we would do in our modern version of the game. In Battle for Azeroth, if we saw this, we would have an artist come and pick an appropriate color, maybe like a soft yellow, maybe an orange, whatever they wanted for the correct aesthetic. But for us, we have a different goal. We want to recreate it as it was, authentic as it was. So we put it back exactly bright, pure white. And so if you guys check this out in the demo, either on the show floor here or at home, and you go and take a look at this lamppost, you will see that it is white today. But that one's purple. It turns out there are more than one Westfall lamppost model. They look really similar. They even have the same bug. There's two of them. We'll fix this one too, don't worry. We're not done yet. There are other things that weren't able to be solved by just restoring old data. It got us a long way, but there are some things where even when we restore the old data, there is no system that understands it. A great example of that is provided by the Hunter and his class abilities. The Hunter had things that aren't represented in our current engine anymore. Things like pet training, or pet happiness, or pet loyalty, and we needed to bring those back too. We had the data for them, but we needed code that would read that data. So we went back to that original source code, and we were able to surgically remove pieces of it that would support that data and bring them forward into our modern game. So we have been able to restore these systems. I don't have a lot of funny stories about this, except for some people forgetting that they needed to buy ammo. Or some hunters whose pets ran away when they forgot to feed them. We brought all this back. It's not just hunters, of course. There was also rogues and their combo points being on the target. Our modern resource and combo point system doesn't understand anything about changing targets. We had to bring that code back. And there's also things like the combat formulas to make sure that your critical hits and your crushing blows are distinct and are affected by the defense skill of the defender and the weapon skill of the attacker. And we brought back weapon skills as well. We brought back the code that levels up as you use them more, and the combat formulas that make them affect your chance to get a glancing blow. There were also animations. There's a pretty obvious bug here on this screen. That Plane Strider is dead, but he's standing up. I'm looting him. How am I doing that? I can even skin him. Animations are stored across all three of those basic building blocks: the source code, the art assets, the data, and they all contribute different things. So restoring those, we had some problems. And it affected one of the most iconic quests that I'm sure a number of you have remembered and gone back to re-experience. I'm sure you guys all remember Man Crick's wife. So we, of course, named her Olgra in the expansion. I'm sure some of you remember that. In Cataclysm, we made a memorial to her and declared that her name was Olgra. But of course, in 1.12, she was only known to you as Beaten Corpse, because you were supposed to discover her and find her dead, and she's standing up, like the Planestrider. It seems a little bit odd to be interacting and inspecting a dead body that's standing up in front of you. Well, maybe not for the Horde. In any case, we were able to find these bugs, we were able to track them down, we were able to restore it, and now all of our animations are playing correctly. You can go and get revenge on the Quillbore for what they did to poor Mancrick and Olgra, and you will see them lying dead when they are dead. I also want to talk about some of our classic UI screens, like the character customization screen. This is something you see very early in the game that's really near and dear to our hearts. It has great feelings of nostalgia for all of us, and I'm sure for you too. And when we look at the prototype, we had the correct race and class combinations. We got that from the data, but the art is wrong. And so we went and restored that art. And here we ran into another case where restoring the art was not enough. When we look at these two screens, they're a lot closer now, but the reference client seems to have almost a snowy effect, whereas the prototype here, or our work in progress rather, does not. And we went and looked into this. It's not weather, it's not snow, it's actually a fog effect. And we were able to find the engine equations that controlled that and restore them a little bit closer. I don't want to promise pixel perfect perfection, because we might not hit it. But we are doing these side-by-side comparisons all the time, and we're going to work as hard as we can to get this as close as possible. On that same subject, I want to talk about Elwyn Forest. Here's an example where we went through at one point in WoW's history and we changed all of the lighting equations, and our environment artists went back and plugged in new data values to control those new equations and make things look correct for that version of the game. And so when we wanted to rewind those changes, the first thing we did was put back the old data, and we got close, but there's still some problems, like this really bright light over here. This doesn't look right. You can also see the shadows are slightly different, the fog is slightly different, but focus on this light for now. That light has a really hard edge. It's really way too bright. And when we dug into this, we found that what was controlling this was the distance fall-off equation. This is an equation that controls how much light is projected onto a texture based on how far away the light is from the thing that it is lighting. And so when we saw that this was different, we dug into it, we found the formula, and we were able to make adjustments in the code to make this look much closer. We fixed the shadows and the fogs a little bit too. So now we're much closer. I imagine at this point, you guys are wondering one of two things. Are you done yet?